Hello and welcome in this session. This is the 14th session of this tutorial series. Today in this session we are going to cover solve differential equation using Fourier transform, Laplace transform and Z transform. First of all, once again, good evening all of you, and I hope all of you are doing well. And in the last session as we cover the topic, I hope you have covered. If you have any question or any query, you can put your question in the chat box. I will try to justify you. If I am perfect audible to all of you, please let me know by putting in chat box so that we can start. Okay. I think I am perfect audible to all of you, and I check from my side. Voice is very clear and network from my side also perfect. So the thing is, integral transform play a very important role to solve different type of differential equations, differential equations. And today in this session, what I have done, I have prepared the presentation as well as the script file so that in less time we can cover these three topics. Otherwise, while writing the code in the MATLAB, it will take more and more time because the script file is too much long uh, to expand all these step by step. But the most important thing is if you have covered the previous sessions and you solve some differential equations, those previous sessions will help you in this session also. So first of all, I would like to share. Yes. Uh, okay. So now you can see this is the my desktop and topic solve differential equation using Fourier transform, Laplace transform and Z transform. So these three transforms will be discussed in this session. Good evening, Vani, Slaudin, Anathony, and OKK. Thank you very much to joining the session. Okay, so this is the main agenda of the today's session. Uh, First, we will use Fourier transform to solve the differential equation and the definition of the Fourier and inverse Fourier transform concept using symbolic workflow, how we can use the Fourier transform and then we need to apply inverse Fourier transform to get the solution. But the most important thing is we will focus on the computing part only. So that I would like to skip the theoretical part because I thought that the theoretical part you have covered yourself, you can do easily. But in this session, if we focus only on the computing part, this will help you. Okay. So if you need to clear the theoretical part, you should cover from the textbooks available everywhere. Then we will calculate beam diffraction using Fourier transform. This is the one example. And in the second part, we solve the differential equation using Laplace transform. First, we will discuss about the concept by using the symbolic workflow. And then we will present here one example, solve RLC circuit using Laplace transform. And the third one is we have Z transform. So this is also the similar type little bit. I did not introduce here, but we will cover Z transform through the MATLAB directly. Okay. So here is the Fourier transform, and the Fourier transform is a powerful tool for solving differential equations that involve non-periodic function. It works by transforming the differential equation from the time domain to the frequency domain, where it can be solved more easily. The general idea is to take the Fourier transform of both sides of the differential equation. Then we need to solve the transformed function, and once the transformed function is known, it can be inverse transformed back to the time domain to obtain the solution. So this is the main procedure. First we will we will apply Fourier transform on both sides of the given differential equation, and after solving it, then we need to apply inverse Fourier transform. So when we using the Fourier transform or Laplace transform or Z transform, uh, all these three transform, there is some similarity. First, when we will apply transform, then after solving, we need inverse transform also. So first, there are some few definitions of we have the definitions of Fourier transform. Okay, just 1 minute, please. Why the marker is not working? Just pen. Okay, Epic Pen is not working. Just I have to reopen the file. 1 minute, please. Yes, just one. Have to. Yes, now it is fine. Yeah. Okay. So in this section, we will discuss about the workflow of the Fourier and inverse Fourier transform and symbolic method toolbox. So symbolic method toolbox is a specially inbuilt tool in the MATLAB, which we can use for different type of symbolic calculations. Okay. So for simple example, see here, these are two functions in the MATLAB. These are inbuilt function. So first one is used for the Fourier transform, and second one is used for the inverse Fourier transform. Okay, so when we will write the script file for the Fourier transform, which is defined as in this equation, and the inverse Fourier transform is defined in this equation. Okay, so when we will use in the MATLAB, just we will use this Fourier inbuilt function, and for this expression we will use I Fourier function. So both are well defined in the MATLAB, and just we need to understand how these two functions we can easily use in MATLAB. while solving the differential equation. Okay, so we need to understand when we are given the differential equation, uh, what steps are involved to solve the same. Okay, so here is here is on the next page. Uh, this is the concept about the Fourier transform. So the symbolic workflow keeps calculations in the natural symbolic form instead of the numerical form. Okay, this approach help you to understand the properties of your solution and use exact symbolic values, and then we will substitute numbers in the place of a symbolic variable, and only then you required a numerical result, or you cannot continue symbolically. So these are 5 steps. First we will declare the differential equation, then we will solve the equation, then we need to substitute the values of the parameters which are involving in the differential equations, whether it is the initial condition or the value of the other parameters. Then we will plot the result after getting the solution. We will plot the results and then analyze the results. Okay, so these 5 steps will involve for this computing. Okay, and okay, Ali Musa, good evening. I am very happy to see all of you in my session, and you are always with each session. Thank you very much. Now, we have this is the we have one example uh, to calculate beam deflection using Fourier transform. The image is also there. You can see the Fourier transform can be used to solve ordinary and partial differential equations. For example, you can model the deflection of an infinitely long beam resting on an elastic foundation under a point of force, as you can see in this diagram. And corresponding real world example is railway track on a foundation. The railway track are the infinitely long term, while the foundation is elastic. And here you can see this is the stiffness, which is a constant, and this is the in this direction we have road bed, and this is the road rock shocks. All you can see y-x the variable which is vertically downward, delta x is also downward. So these are the parameters which we need to consider here. A be the elasticity of the beam or the railway track, I be the second moment of area of the cross section of the beam, and K be the spring stiffness of the foundation. So on the behalf of these parameters, as we have the differential equation which is from minus infinity to infinity. Okay, uh, we want to solve this equation, but I did not go through more detail about the how we can establish this differential equation. This is not the part of the session. Just I choose here this example, and how we can solve this differential equation using the Fourier transform. Okay, so first of all, we need to convert this differential equation in the MATLAB syntax, and also I let you know that with each step, we I have prepared the script file also, and corresponding all the statements I would like to execute and get the corresponding numerical results also. Okay. So first you can see we need to declare the symbolic variables, and you can see yx is and is a function which will involve after getting the solution E, I, K are positive. So sims is used to declare the symbolic variables yx, E, I, K, F, and W. And also we need to assume that these all are positive. So we assume that E, I, K are greater than 0. After that, by using uh, this function, which is sim unit, we need to convert all the uh, parameters which are involving here because all have a different unit. So according to that, we need to convert all the variables in corresponding to their units. Okay, so we are using this function u is equal to sim unit. Then we will convert this EU, which will be in Pascal, A product U dot PA. Okay, this is the one unit. And similarly, we will convert I, and this is the assignment to after converting the I. Okay, so IU is the symbol assignment, and this is the transformation. By using we can easily convert. Okay, so this will be I product U dot M raised to power 4. We need meters. Similarly, we can convert K into sim unit, symbolic units. Okay, so this will be equal to K product U dot N upon U dot M square, Newton meter square. Similarly, we can convert X also. Right? Yes. So X will be equal to X dot X product U dot M, and F will be equal to F product U dot N upon U dot M. Okay. So these are the symbols to convert in unit. Now, the next, the most important step we have is to define the differential equation. So this is the equation, is the assignment, and as you know, single equal is used for the assignment. So the differential equation is starting from this place to this place. Uh, this is the left hand side of the differential equation, and this is the right hand side. Okay, so you can see we have d 4 y upon dx4. Okay, so this is the part, and then we have ku plus we have ku upon eu into we have iu product y. Okay, is equal to f upon au into iu. So this differential equation can be written as, at the place of equal, we are using here double equal. Note this point very carefully. Double equal is used for equal, and single equal is used for the assignment. So this entire differential equation will be stored in EQN equation. This is the one assignment. Okay, see once again. So from this place, this entire differential equation will be stored in this assignment. Okay. After that, F, we need to replace force F by direct delta function, which is acting vertically downward as you saw in the diagram. So subs function is there. We use subs function to pass the value. So here we are, we want to pass the value F is equal to delta X. Okay, so this is the equation, this one, and F is being replaced by delta X. So we are using here direct X. Okay, so F has been replaced by using this equation. Now after that, we want to solve this equation, and to solve the equation, we we will use the Fourier transform. Okay, to the equation, and you can see here equation ft. Here ft means Fourier transform to this equation. But to the given equation, we have left hand side and right hand side. So Fourier LHS, this is the Fourier transform for left hand side of the equation. This part only, you can see you need to compare these two equations. So in the above equation, this is the left hand side, okay, and this part is right hand side. Okay, so Fourier transform to the left hand side of the equation is equal to Fourier transform to the right hand side of the equation. So when you will execute this statement, we will have the solution. See in the MATLAB also, it is very important to see in MATLAB. Yes. So the thing is, I have prepared the script so that in less time I can present all my content which I have prepared for this set. Okay. So I have write a very beautiful script file. Everything is there. See, as you know, CLC and clear, close all, we are using to clear the command window, to clear the functions, and to close the windows. Okay. Uh, these are the same statements as you see, as you saw in the PowerPoint presentation. Okay. And these statements are used to assign the unit to the variables by using semi-unit. Same. Then we have equation. See, this is the equation. Okay, so this is the symbol uh, for the assignment of the differential equation. The right hand side information will be stored in EQN. Okay, so this is the left hand side of the given differential equation and the corresponding syntax of the differential equation. Okay, and this is the right hand side. Double equal means equal to, is I have already explained that double equal is used for equal, and single equal is used for the assignment. Okay, so also we pass delta x in the place of f by using the subs. This we have also discussed. Okay, if you will remove this semicolon, as you know, why we are using semicolon, just suppress the statement. The statement is the part of the program, but that will be executed. Okay, so when you will remove this semicolon and then execute the sequence of statement, you will see here, you will see, just 1 minute, you will see, yes, this is the differential equation. Okay, you can see here, and to press it, here is at the place, yes, this statement we need to, okay. So here then after equation subs equation, we assign the value of f is equal to direct f. Okay. After that, we need to solve the differential equations, and we were discussing about this one. Okay. So EQ and FT, this is the just assignment, and on the this is the Fourier transform of the left hand side of this differential equation. Okay, and this is the Fourier transform of the right hand side of the differential equation. Then we need to isolate Fourier. So when you will use this isolate function, This will simplify and get the value of y function from this equation. Okay, and on the right hand side we will have the some function involving x and w. You can check here when we will execute. Yes. Okay. So you can see on the left hand side we have the Fourier of yx, and on the right hand side we have only the function which is involving e, I, w, p, a, etc. Okay. So this is the y function. Then again suppress it. Yeah. So we have discussed about these two part. Okay. So yx will be calculated when we have the value of y. Then after, what we need to apply inverse Fourier transform. And inverse Fourier transform to the right hand side of the above equation. Okay. On the left hand side we have only the assignment. See once again at the above equation. Yes. See, we isolate here. Okay. And this is the only assignment. And on the right hand side we have the yx. Okay. So yx is the isolated value of the above differential equation after taking the Fourier transform. Okay, so we will take inverse transform to the right hand side of this equation. See this syntax very carefully. So when you will apply inverse Fourier transform to the right hand side of the above equation, this is the real solution of the given differential equation. So we will store the result in y solution. But this is not sufficient. We need to further simplify. We will use the simplify function to solve this expression. Okay, and after that, note all these sequence of a statement. After getting the solution, we need to check y solution has the correct dimensions by substituting y solution into equation and using the check unit. This is very important to check the units whether all these are involved or not. Substituting means when we will substitute this value in the given differential equation, then this must be justified, or this must be true. Okay. So when you will check units, check unit will return the logical 1 2, meaning equation now has compatible units of the same physical dimensions. Note this point. So the parameters which are involving after getting the solution, we need to assign the values of the parameters which are involving in the solution or in the differential equation. So the physical dimensions must be same. Only then we have the solution of the given differential equation. So we are using here check unit. Okay. Then subs function is used to substitute the values. This is the equation which is the differential equation, and the meaning of y. In the place of y, we will pass this value, y solution. Okay. So in the given differential equation, y is involved. So this value will be substituted and we will check it. Okay. So see in the MATLAB, this is very important to check here. Okay. See this step very carefully. Yeah, this is the part. At this place, we will check the unit. Okay. I have comment all these sequence of statements so that only we have the result of this statement on the command window. So when I will remove semicolon, we will have the result corresponding to this statement. Okay. See, you can see answer consistent, 1 and compatible. Okay, so 1 means true. So the physical dimensions are compatible and we can have the solution. Now uh, after that we have separated the expressions from the units using the separate unit. Okay, we will use this function. This is also the inbuilt function in the MATLAB. So see here, y solution, we are using separate unit for y solution. Just we need to pass the value at its place. After that, we need to substitute the values of each parameter. And these are the corresponding value. E is equal to 10 raised to power 6. Then we have I, K, okay, and substitute to these values into the y solution and convert it to floating point by using VP. If we will not pass, we will not use this VPA, then we are not able to find out the solution. So we need to use at its place. I have detailed explained in the previous sessions. Okay, many times we have the solution, but not in the numerical or float format. For that, we have to use VPA. Okay, so these are the values. We have assigned the values for these parameters, as you can see at its place. These are the values, and then y solution subs function is there, and we need to pass these values. Okay, so y solution, and these are the parameters E, I, K, and then the values of these are in the above equation. So we are using here subs function to assign the values which are particular values of E, I, and then after y solution is equal to VPA, y solution, and this will return the solution up to 16 digit decimal places. See in the MATLAB. Yes. So first we need to use at its place semicolon. We are using here semicolon. Okay. Then after we are using the separate unit, and these are the values which we have assigned, and we want to check this value. Okay. The sequence of statements in this script file are the same as are given in the presentation. So don't worry about the script file. I will provide you the PDF file. Okay, you can easily use these syntax and you can prepare your own script file. So when you will remove this semicolon and we want to check the value after using this one, see, yes. So here you can see is digit. Okay, these are numerically calculated and each are about 16 digit in each case. Okay, after that it is the time to plot the graph, and we can use fplot function. We discuss about EZ plot, fplot, and when we are using fplot or EZ plot, If you have the MATLAB older than 16 R, then you will use EZ plot. But if you have the MATLAB version 16 or latest version, then you will use fplot function. So by using the fplot function, we can easily plot our solution. Here you can see this is the x label, this is the y label, and grids are on. Okay. So when I will execute this sequence of a statement, you can see this is the solution of the graph of the solution of the given differential equation. So this is the simple process. First, you need to convert the given differential equation in the in this form. But before that, you need to declare the symbolic variables, which variables are involved in the given differential equation. And first, you need to define and also the parameters, and then you need to convert each parameter into the symbolic unit. This is very important to convert before writing the differential equation. After that, just you need to take the Fourier transform and then inverse Fourier transform, and at the end you can easily plot the graph. So these are the sequence of statement for the to find out the solution of differential equation by using Fourier transform. All these sequence of statements are not easy, but it will take time to understand all these. Syntax are very important. Along with you need to think how you can convert the given differential equation into the syntax of the required format. You can use Laplace transform, you can use Fourier transform. Also, for finite difference equation, we can use Z transform. Okay, so all these have some little bit same pattern to use. If you have any question, sir, please send the link to download the MATLAB in the PC. Vani Madhvi, uh, you must contact me. You can download Vani Madhavi. You can use a trial version of the MATLAB, which is available for 1 month. Okay, you need to create MATLAB account. Just see in the see here. Here is MATLAB. This you need to go to MATLAB official website. Okay, here is yes, MathWorks. This is the official website, and you can click here to get the MATLAB. Sorry, I think my voice was not getting by you. Just now I check that my voice is not there. My mic was disconnected while the interruption. Now you are getting my voice. Please let me know. Are you getting my voice? I am audible. Please let me know if I am audible. Are you getting my voice? I hope my voice is there now. Okay. So once again, I am asking if you have some doubt regarding any question. I can repeat the same. The content from each side has been presented today. Sorry for today's interruption in the internet, as well as power cut was there. Due to power cut, I faced the problem. Okay, now I think everything is fine, but if you have any question, please let me know. Uh, okay, also I have the solution. I will record the lecture and I will provide you. Okay, I will try from my side. Also, I will try to provide all the content which I present here. Please let me know if you have any question for the present discussion. I came to know that my voice was disconnect. Anthony Okeke, Aliyu Musa, Johan, Vani Madhavi, please let me know if you have any question. Are you getting my voice now? I can see chat box. If there is any question, you can put in the chat box. Okay, so these are the content for the today's session, and This is a time to end the session. I chose three examples for these three transforms: Fourier transform, Laplace transform, and Z transform. Okay. Should I close the session now? If you don't have any question, okay. Thank you for the today's